Okay, so this is the workbook 27, and I'm just going straight to the problems. So the sine of z, so here's z, sine is the opposite, it's the so it's the opposite over the hypotenuse. So it is xy over yz, xy over yz. And the cosine of z would be the xz over yz, xz over yz, and then the tangent would be xy over xz, xy over xz. There we go. So it's all doing this. So if you don't know how to do this, watch the other video. Then right here, we are supposed to do the ratio of the sine of c. So here's c. So the opposite is 72. The adjacent is 97. So it'd be 72 over 97. Then let's double check. 72 over 97. Yep. Okay. And then right triangle, we have all this stuff. What is the cosine of s? So here's s. The adjacent is 48. The hypotenuse is 73. So it's 48 over 73. And then we know that the sine of c is, so here's c, so it's 3 over 5. And so if we use the Pythagorean theorem, that's going with unit 26, or workbook 26, we would have 5 squared minus 3 squared. Doing it in my head. 5 squared I know is 25. 3 squared I know is 9. 25 minus 9 is 16. So the square root of 16 is 4. So that would be 4. If you don't see that, write it down. And I want the tangent. So it's going to be 3 over 4. So because it's the opposite over adjacent. So 3 over 4. So that is a quick view of the only problems on workbook 27.1. And then can we go to the next one from here? We can if I move my video. Again, I'm going to go straight to the problems for these just because I've done that. I think I explained everything in another video, another link, the other link. So the sine of 35 is equivalent to which value? So for these, if you have a right triangle, 35 and the angle over here would go together and it would be the cosine of that. So you do 90 minus 35. So let's see, 90 minus 30 is 60, minus 5 is 55. So it'd be the cosine of 55. And then moving my camera again. Then 87, same type of idea. We're going to do 90 minus 87, and that's 3. So it's going to be the sine of 3. Pretty good. Not too bad. Should get 100%. I did. Good thing. Next. This is all trigonometry stuff, and I think it's awesome. I love trigonometry. I'm sorry that you didn't have a great experience with it. Hopefully you did have a fairly decent experience with it, but having an awesome experience with it, but the best. So these are frustrating for me because they gave us this decimal approximation, and the decimal approximation gives us one answer, and the actual answer is something else. So it's really sad. So we have the measure of EF as we want to find, is what we want to find. We are given the hypotenuse. So EF compared to 26 is the opposite. Opposite and hypotenuse have to do with sine. So I would write down, if I were to do this just with writing it down, I would write it down like this. So I'm going to pause while I get that set up. So the sine of 26 would be the opposite over the hypotenuse. So the opposite side is what we don't know, and that is EF. And then the hypotenuse I can see is 4.5. I'm going to do little equations in here, and it looks very unprofessional. So it's the opposite side is EF. The hypotenuse is 4.5. So I'm just going to rewrite that just so I can do the math on it. So the sine of 26 is equal to EF over 4.5. I want to solve for EF, so I multiply both sides by 4.5. And then we're going to use the decimal approximation that they gave us. And actually kind of rule of thumb that I figured out is if they only round it to 2 decimal places, you're going to get the answer wrong because they did not include that. Actually, I'm kind of willing to test it. So we're going to do 4.5 times by 44.44, which is what they told us that we were supposed to do. If you're doing it in your calculator, make sure that your calculator is in degree mode, or if you're just going to do it with the decimals, just do it like this. That was from lesson 26. So 4.5 times 0.44 is 1.98, which is the answer that we got right now. I believe that the answer that they gave us was actually that you're supposed to have is 1.97. So we'll see how good they did at this. I kind of think that they didn't fix it. This one, when it goes out 3 decimal places, then it works. So I just, I used my calculator. Oh, did it lock? It did. It stopped working. So let me go back and fix this really fast. Sorry for having to wait. Okay, so I used the Desmos calculator to do the last calculations like this. Okay, so 1.98 is what we got. And then we're going to come back and do this one. So for this one, we have, we want to find AB. AB is the hypotenuse, and we are given the adjacent to angle A. So the one that uses adjacent and hypotenuse is the ka. So we'd have the cosine of 52 is equal to the adjacent side, which is 10, over the hypotenuse, which we don't know. And so that is CB or BC. No, we want AB. Just kidding. I meant to say AB because that's literally what it says right there. And I have it set up correctly for that anyway. Okay, so this is what I have. And it stopped working again. So I'm going to push pause this time and make it actually work. Okay, so we were given the adjacent. We needed to find the hypotenuse. We were given the adjacent. We needed to find the hypotenuse. So the cosine of 52 is equal to the adjacent, which was 10, over the hypotenuse, which we didn't know, so we put AB. We want to solve for AB. Longer story made shorter with this is with like the math preloaded part, is we can just switch those. So AB would be equal to 10 divided by the cosine of 52. And if we use their decimal approximation, which they gave us, that the cosine of 52 is 0.616. So coming back here, 0.616, I can do it in the calculator. 10 divided by 0.616 is 16.23. So we're going to use that. So 16.23, and let me double check that it didn't need to round anymore. Nope, that's what it would be. Okay, and then the last one here. So it's giving me a red flag in my mind because I know that if they round to 2 decimal places, there are mistakes, and then it says that you get it wrong. But I am doing this correctly, so there's that. So this one, I can see that I am supposed to find HI. HI is a leg, and I'm given the other leg. And the only one that has to do with both legs is the TOA, the opposite and adjacent. And I'm given that from angle G, I'm given the adjacent, and I want to find the opposite. So look at how I write this down here. So here I have the TOA. I'm given the adjacent, and I'm wanting to find the opposite. Sometimes I write it down like this to help keep myself, help keep track. So I know that that's 11. And so I'm going to write this down. So the tangent of 42 is equal to the opposite side. I don't know it, so I'm going to put an X there, over 11. So the tangent of 42 is equal to X, the side that I don't know, the opposite, over the adjacent, which I do know. So I can multiply both sides by 11 to solve it. And so they told me that the tangent of 42 is equal to 0.9. So 11 times by 0.9 is, and so let's just make sure we have everything set up right. We want HI. So good. We're going to go to the calculator. 11 times by 0.9. Oops, wrong thing. 11 times by 0.9 and 9.9. You could have done that in your head. But There we go. So we should have 9.9. Tangent of I is what I did. No, is what I did. The tangent of G was the opposite, which I didn't know, over the height adjacent, which is 11. And then I times it, so it should be 9.9. So I've done everything correctly, and we'll see what they say. This is the frustrating part with 27, because I think that a lot of students think that they're not doing it wrong, right? Because of the decimal approximations. So if you got this score, know that this is going to be one of the assignments I will probably drop for you. And I think it just swept your confidence in this topic out from underneath your feet, because it is strong mind, and I've tried to have them fix it, but they seem to not understand. Darn it. Okay, so now we'll do the checkpoint, and I know that there's going to be problems with it also, with the decimal approximation, which is why I am dropping some of these assignments. Checkpoint 27 has the most problems I think I've seen in a long time anyway. So the ratio for the sine of B. So here's B. Sine is the opposite over the hypotenuse. The opposite is 12. The hypotenuse is 13. So it's going to be 12 over 13. 12 over 13. Then this one, cosine of 15. So then 15, so 90 minus 15. So 90 minus 10 is 80. Minus 5 is 75. So it'd be the sine of 75. I already had the cosine. The tangent of A is the adjacent over the opposite. So 45 over 28. And then this one, this is going to be okay because they're using 3 decimal approximations instead of 2. So we want the measure of BC, which is the hypotenuse, and we are given the opposite. So I'm going to use sine. So I know that the sine of 44 is equal to 10 over BC using my thing here. I'm going to come back. Well, okay, so then I'm going to write it down because it makes more sense to write it down. So I'm going to go back to the problem to see what it was. So we have the sine of 44 is equal to the opposite, which is 10, over the adjacent, which we don't know. So those would switch. So I'm going to do 10 divided by the sine of 44. And I'm going to show you how I would do it with the calculator, because, completely with the calculator. So I would do 10 divided by, so if you push on functions, there's sine in there of 44, but then you have to make sure that your mode, going up to the little up thing at the top there, is in degrees. So I get 14.395, so it's going to be 14.4 is what I'm going to put in there, because it would have rounded up, so 14.4. And again, it might give a wrong answer, but I would rather show you how to do it the right way rather than depending on their poor decimal approximations. Sine of 42, 90 minus 4. So I'm going to use a cosine, so it's for sure going to be a cosine one. They got that. But 90 minus 42. So let's see, 90 minus 40 is 50. Minus 2 is 48. So it's the cosine of 48. And then this one, we want to find YZ. YZ is the adjacent. I'm given the opposite. So according to the SO and the KA and the TOA, then what I'm given is, if I look at SO and KA and TOA, opposite and adjacent only have to do with the TOA. And I can see that my opposite side is 7, and I want to know the And I know that the angle is the tangent of 16 degrees. So maybe I can even set it up like this. So I have 16 degrees. I know that the opposite of 7, and I want to find the adjacent. So I could write the tangent of 16 is equal to 7 over the thing I don't know, which means that those can switch places. That was the preloaded math idea. So x is equal to 7 divided by the tangent of 16. I'm also going to use my calculator for this. So it was 7 divided by the tangent. So function tangent 16, and it's in the right mode. So it's going to be 24.41. So coming back here. Oh, it says 1 decimal place, so 24.4. 24.4. then I should probably check that on the other ones. Ooh, let me hurry and go back and check. Ooh. Good. Okay, I think everything else was just ratios. Okay, so we needed to do number 8 still. Okay, good. This was nice and easy. So angle A is a right angle. C is 15/7. So I'm going to draw this triangle because for me, when I draw these triangles, it makes more sense to me than just trying to duke it out in my head or anything. So it says that the sine of C is equal to 15/17. So here's A, B, C, right triangle. And I want to find the cosine of C. So I'm going to draw. I drew it out right here. And cosine of C, so here's angle C, is 15/17. And I can see that in order to find this one, I'm going to need to know that side. And I can do the Pythagorean theorem. So I'm missing a leg. So on lesson 26, I said you can do the square root of 17 squared because I'm taking the hypotenuse squared. So the square root of 17 squared minus 15 squared. Doing that in my calculator. So square root of 17 squared minus 15 squared. I got 8. So coming back here, I get 8. And then I want the cosine. So the cosine of C is the adjacent. So that's the one right there over the hypotenuse, which is 17. So we would just put in 8/17. Right here, 8/17. And I know I've done everything right. Double check things, right? Oh, no. Cancel. Apparently I didn't finish number 7. Okay, so 17, and that's 62. So let's see. So I know that J, let's look at that thing. Oh, did I even show the last thing? Did I show this? I did. I got 8. Oh, and then we had the cosine, then we did this one. Okay, good. Coming back here. So we want JL. JL is the adjacent side. And then I'm given the hypotenuse. So I can tell that that is cosine because we have adjacent and hypotenuse. So the cosine and the angle is 62. The adjacent is what I don't know. And the hypotenuse is 17. So coming back to how I wrote this down. So I wrote down ca of 62 degrees. I don't know the adjacent and the hypotenuse. So the cosine 62 degrees is equal to the adjacent side, which I don't know, divided by 17. So I'm going to multiply both sides by 17. So 17 multiplied by the cosine of 62. So 17 multiplied by the cosine of 62. By the way, your calculator, if you're using decimals, always defaults to do the radians. So you could check a couple times that it's in degrees. You see that there? And it is. So we got 7.98. And let's check what decimal place they wanted us to round to. So if it was 17.98, I'm going to use their decimal approximation because it's going to be iffy. If I rounded that one to one decimal place, I would get 8, but that may not be what they want. So I'm going to use their decimal approximation. So 17 multiplied by, and they said that the cosine of 62 was 0.47. And I got 17.99. So yep, I'm just going to have to round it to 8. Oh, not 89, just 8. Let's see. And did they mark things wrong because of rounding? Probably so. They did. In fact, let's just double check what they did. Ooh, okay, let's see. 45/28. We're supposed to do the tangent of A. I got it mixed up. We were supposed to do the tangent of A. I did the tangent of C. So that was my fault. Everything else was good with that one, though. That's a good news thing. If we use the decimal approximations, we could have gotten it wrong. But for the sake of time, I'm not going to go back and do this one because 87.5 is not a bad grade.